just on my background, so that what are some of the spots that I pay attention to, what are the spots that I don't have as much experience in as we go along, and definitely please ask questions along the way. But I kind of started out in college fixing bugs for 15 bucks an hour part-time on an ASP app. I tried doing law school. That was a bad idea. I did Epic for 10 years. That was a good idea. And I did about 5 years of security app analysis while I was there. And I'm now working at site reliability engineering for a cloud-based service provider. So for the agenda today, I want to kind of cover this from a theory perspective. What are some of the concepts that I think are helpful to hold in your mind when you're thinking about application security and mobile security? What are some of the techniques and things that you're looking for if you're trying to reverse engineer or understand how something works? And also, so you can be cognizant of what people who are doing that for an adverse purpose are likely to be doing, likely to be looking for. And then go over some of the kind of defensive practices and measures. What are the ways that you can try to mitigate that? What are the ways that you want to design into your apps and services so that, I think at the end of the day, what is the, how do we calibrate where we are on the spectrum from, you don't trust anything, you can't plug it into the network, it doesn't exist, to putting the password under the keyboard. So how do we calibrate that with the time and effort we spend on things? Kind of ground thoughts, ways of thinking about things that become helpful along the way. Distinguishing authentication and authorization is somewhere that I think from a software development and application ownership perspective, we see a lot of people kind of just say auth, right? And say, well, I implemented auth, or I got auth0 for auth. And there's really, I think, two parts of the coin that they need to be keeping in mind when you're designing the services. One is, am I who I say I am? How do I validate who that person is? The traditional username and password is the kind of core concept for that. But then also the authorization layer. What are the parts of getting up from, I trust that you are who you said you are, to, and you're allowed to do what you're asking for. So a weak form of authorization might say, you're a valid user, you can read whatever you want to read, right? I trust that you're only going to look at your particular document, your particular page, and I don't put any guardrails around that. As the fine-grained end of authorization, it might say, well, you have a privilege to access this specific row of this specific table, if and only if somebody else has given you a green light in the last 20 minutes. So those are, I think, just keeping in mind as you see people talking about designing auth in their apps. Those two concerns are related, but I think helpful to keep separate. Another mental framework or analogy that we see a lot, I think I see this a lot more in cloud services, is the idea of the confused deputy. So thinking, I think, particularly about the authorization side, but it can affect authentication as well. If I kind of imagine myself as a service, someone comes to present to me a request that I do something, and it's been signed by my trusted partner. Again, whether that's maybe it's a Google sign-in or auth0, maybe it's an AWS key, but it says, hey, this is Alex, and this is what he wants to do. There's a very common, I'll say, pattern of trusting that delegation of trust completely and saying, well, they have a valid Google session, so it's good. I'm gonna let them in. They have a valid token. All the signatures are great on it. And that doesn't get us away from people who figure out ways to get legitimate valid tokens and ask web services to do something else for us. A pattern for this in AWS, when we have multiple accounts in AWS and we want to let resources in one account access another, you basically write permission lists that say, I'm going to trust certain authentication tokens. I'm going to authorize those to access my resources. It's an S3 bucket that's full of documents, or it's a queue that's full of information to process. And when you write those permissions grants broadly, you could end up in a situation where somebody makes their own, free trial AWS account. They make a perfectly valid username, perfectly valid credential. It's just not a credential that means anything to you. but they know what your account number is because someone put it in a Stack Overflow post or somewhere on IRC. And now they're going to try to see what they can find with that. So preventing formally correct but unintended requests from being processed is a big part of this. You also see this, I think, when you have integration for your development pipelines and people are using shared cloud runners in GitHub or GitLab. And again, you say, yeah, GitHub can totally get my my root domain key for pushing these to production. Well, GitHub /Alex/evil maybe shouldn't. So watching for those very wide grants. And then kind of one more conceptual piece for the programmers, for the designers, architects perspective is, what is a trustworthy source of information? And I think from one point of view, this is extremely obvious, and from the other point of view, this is extremely subtle. And I'm writing software all day, and I'm iterating and trying to get it to work. When it works, I'm like, I got it. This is I crossed all these challenges. I got all these frameworks to talk to each other. The document is structured correctly. Great, I can trust it. And hey, I can even check in JavaScript before I hit send on this form that it doesn't have any scary quotation marks in it. I think for folks who look at security, that's a lot more of a immediately grasped concept, that you don't know that who's talking to you is the client that your software developer wrote. So if I'm a server side in the exchange and you give me a document that escapes out of a SQL query, right? That's SQL injection, that's classic. Can happen more subtle ways too. If I'm sending you a JSON blob for a particular API transaction and I break out of that, what's going to happen to the data that is outside of that? Is that going to be processed as another request? Is that going to be direct? Is that going to let me make the service do something that it wasn't designed to do? But understanding in your kind of mental model that you don't know who the client is and you don't know if they have good intention, it's just I think that, again, one of those foundational things that takes time to bake in, especially with newer developers. So to kind of collapse this into a threat model that I wanted to focus on today, who do we want to think about protecting against the most? Definitely malicious third parties, the stereotypical hoodie over a keyboard with a green screen glaring in the face. Ex-insiders, right? People who know how the system really works and have left and carried a lot of that in their head with them, or carried a USB stick full of information. And some interchange of the both, right? There are many different roles in the malware actor world, and people trying to do access brokering and things like that could become the who in this. What are they after? Here I want to focus especially on these cases where we front a resource that we pay for that costs a lot of money. So talking about my AWS compute services or S3 buckets, maybe it's because it has, again, somebody just wants to store a bunch of stuff for free under my bucket. That might be useful to them. Maybe they're trying to stage something to distribute somewhere else. Maybe they're just, whatever that scenario looks like. I think one thing about what are some of the assets, or when do we think things might be under attack? We put a lot of focus on production applications, right? If we say this is our live system, this is what our customers are going to call if it goes down. What I think we can also include in this model, and should include in this model, is when we're working on betas of products, when we are staging or making sandboxes for an issue investigation. How often are we leaving things that are really substantially either having copies of our information or access to the same resources as our production environments, and we're just not watching those doors as closely? I touched a little bit on the why. I might be trying to steal some data. Maybe I'm trying to just leak it. There's ideals-oriented actors. Maybe I'm just trying to ransom it. And then again, resource theft, botnets, crypto mining. Maybe I'm going to proxy off of you. Maybe I just want to put all my continual collection of Windows AMI images somewhere that I can look at later. They make one every month. I like that. It makes it easier for patching, I think. And what are the things we want to think about for how? What are the tools that they're going to come at us with? So just thinking about decompilers, putting themselves in the middle of transactions, just scraping or searching or spamming APIs for anything that looks interesting or sounds interesting, and sometimes reading the documentation. I think I had a mention in here, might have dropped in one of my drafts, but I think the mobile iron vulnerability from, this was earlier in the year or late last year, but there was a mobile iron vulnerability that was basically an admin root endpoint without real authentication on it. Just you could just hit it and add yourself to the system, add yourself to the application, and ultimately take over people's mobile devices, right? Put apps on them, put certificates on them, whatever you want. And that's coming from, am I able to find that endpoint because you have a very nice Swagger file that describes all of your API's endpoints. You have a very nice read the docs that got auto-generated when you use your build tool to create the API listeners. So those are some of the things that, again, similar to the disguised client, very well-meaning thoughts, thinking positively about developer ergonomics and making my product easy to consume. I'm also laying out where all the doors are to the building. And that's okay, as long as you're, I think, cognizant of that when you do it. Any questions about the concepts I started with, or any kind of details? Yeah.
By AITM, you mean asshole in the middle?
Exactly. We're in a vocabulary flux, I think, on that one. Traditionally, man in the middle really can be any kind of attacker.
I've seen Peddler in the middle.
Yeah, that's a good one. But seen the words change a little over time. Cool. So I'm not a reverse engineer. That's not my focus, but I have been a problem solver for a long time. And I wanted to go over kind of how, in the course of investigating an application, trying to take it apart, what am I really doing? I really am looking at something that might be a black box or a gray box and figuring out how it works. When I'm looking for how to get a particular service to do what I want to do, what are some of the techniques and pointers to keep in mind? Definitely other resources will get you much farther on the specifics of individual tools and how to work them. But to kind of sample the menu on this, one of my kind of weird things I think I'm proud of, you do this long enough and you start to recognize what secrets look like when you catch them in transit, when you catch them in files at rest, when you catch them unpacking things. And what are the kinds of things you might want to look for if I'm trying to figure out how an application got the service to do what it wants? I might have a simple bearer token. Flavors on that, like a JSON web token, JWT, which is a base 64 compressed JSON blob that says a claim and an assertion about it and a digital signature. If I see there's AKIA, I'm either very happy or very sad. That's my AWS credentials. There are different A strings that present that, but that and then a little bit of base 64 after that is going to be a credential for Amazon. Azure connection strings, some real kind of semicolon delimited key value pairs, but ultimately, what do we have in common here is we're whispering a secret and saying where we want it to be applied. You also learn to spot SSL certificates and keys, that MII at the beginning of the base 64 string. Again, a private key is maybe going to be my client certificate for authenticating to a service. Maybe it's going to be what I'm signing something symmetrically with in a bad way. But if I can find these, I'm again either very happy or very sad. Where am I finding them? Once I kind of have this sense that I'm looking for. Where I spend a lot of my time is in doing interceptions. So it's a little bit clipped to the edge here, but the red, magenta, pink, depending on your color gamut, columns are the person who's trying to get in. The blue columns are the app, and the green is the one that costs us money when people use it. So what I like to keep in mind is one of the models for investigating here is you can have products like Fiddler or Charles Proxy or others that will You basically anchor your lab system's SSL trust root to a fake trust root that project controls. And then every time the legitimate, unaltered client software tries to make a request out, this intercepting proxy stops the request, replaces the SSL certificate with one that it signs for itself for that session, and then makes a real request to whatever the service is on the other side. And so it terminates the SSL connection in this proxy that is not what the client thought it was talking to, but most of the time, hopefully less of the time over time, but the client will not doubt that the operating system said it's a valid certificate and continue the transaction that way. The app side, of course, doesn't know that it's been intercepted. And so maybe we have a model here where we see how an application makes a request. We inspect that request before forwarding it forward. And when it makes a further response or gets further response from the cloud service, we do that. We get to see what those payloads were. And then from there, we can modify what we're doing. So if I have an application that is saying, let's say it's saying, login, username Alex, password 123. And I look at that transaction and I say, and I see the first response come back and says, password good, send the next reply. I send the next reply, maybe I can send the next reply with that valid token and be someone else that time, if that's a kind of weakness I'm finding. Maybe I'm going to get a key, a session key or something that I can reuse from a different place or a different time that's more convenient for me, or I can modify the request in some way before sending it. So being able to intercept traffic, observe and modify it. And again, there are a lot of tools for this, and I don't think I would do justice to any particular one of them in great detail, but knowing that there's a whole space around this on grabbing those and modifying that traffic. That's a big part of our threat model. Aside from catching stuff on the wire, which again is kind of where I like to spend a lot of time, I might also be doing static analysis. I'm going to use simple tools like strings to just find sequences of text in a file. JQ, if I have this big dense JSON blob and I really want to drill down to one particular key in it. If I have an Android app, I'm decompiling Java. If I have an iOS app, I'm decompiling ARM code. I'm especially looking for these config files because these config files are going to have those keys. And again, maybe my developer friend made a choice of putting a bearer token and baking it into the app because, well, it's signed on the App Store, right? So nobody can mess with it, right? No, I can get the IPA, I can get the APK, and get those. These also give me, at least if they don't give me a secret, the names of things in particular, or what are endpoints that are going to be interesting from what the symbols are named, could give me something that I focus on with one of my on the wire tools, where I'm going to say, well, I'm looking for when it does the stage 2 handshake business listener bean factory to make up some enterprise gibberish, because that's what it's going to be called when you look for it, right? It's not just going to be login. That'd be fun. So those are again some of the ways I approach. If I'm looking at something where I don't have the code, or I don't have all of the code, and I want to get an idea of what secrets it's wielding and where it might be using those in a way that I can reuse or abuse. Those are some of the techniques that I'm going with. Any questions about that, about those parts or tools or techniques?
Well, what tool are you using to capture the traffic in between the windows?
Oh, sure. So let me go back here. If my base machine is Windows, I'm probably using Fiddler for this type of intercept. So, if I'm doing packets, I'm just snarfing packets because I'm somewhere that is on Wi-Fi or whatever. I have Wireshark for that. Wireshark's not going to open the SSL connection. Intercepting proxy goes that step further of writing its own certificates on the fly and presenting these fake certificates to the app. There are techniques like certificate pinning, for example, and pinning the revocation list location for a particular domain that you'll see things like Microsoft apps use this in particular, which is a really strong way for them to keep people from intercepting what a Microsoft app is doing. Like, not that I've tried that, but just incidentally, right, in the course of looking for something else. But a lot of the times, especially in kind of things that are coming to market fast or things that are being developed, maybe community projects and things like that, you might not have that option, and so that lets me get in there and see what's actually passing between the players. On Mac, I've been using Charles Proxy lately. I think Charles Proxy is cross-platform, so it probably don't work on Windows too, but I started on Windows with Fiddler, so I mentioned them. Probably other tools as well. I think probably omitting a couple. Say again?
Proxyman for Macs.
Proxyman. Yeah. Cool. So pivoting to what are some of the defensive practices, or what are some of the things that we would do as a software vendor, as the as the white hats guarding the castle, however you want to frame that. The main message that I want to instill in everybody who's putting something together and putting something out into the world is you're never going to get to 100% trust. I think conceptually, there are a lot of measures we'll take. There are a lot of things we can do, and we can make it really hard and really expensive and really time consuming. But if your app code, your little piece of silicon in somebody's pocket or on somebody's phone, can do something with enough motivation, enough time, you will want to assume that your attacker can do that too and act accordingly. In a lot of cases, you're accepting that risk, right? We're talking about a continuum from unplug it and air gap it to just put the password in the binary. You're probably not going to be all the way at unplugging it, but you should still kind of keep that in mind as you think about where you're placing secrets and where you're placing these privileged access. And kind of another frame for that, people talk about it as, or the analogy is a brain in a vat. I liked this image because it was public domain from the Spanish Wikimedia Commons. Estoy jugando al fútbol, I'm playing football or soccer. But you're not going to have a particular reliable means as the application to tell that you're under observation or that your inputs and outputs are being manipulated, that there's not a debugger coming in running code, injecting or extracting values. There are countermeasures to those. They have limitations. But again, assuming that your code is not necessarily the code that's running. One of the mitigations that you have, especially on mobile platforms, is the family of things, trusted execution environments. Apple calls it a secure enclave. Android's term is hardware-backed key store, but putting your core cryptographic operations and your key materials in this really tiny part of your processor that's compartmentalized, that regular code doesn't get to inspect or set debug flags into or read or write memory, unless you have a really cool conference presentation about that. That's really good for keeping your actual key secret, for keeping your actual cryptographic operations from being tampered with. That doesn't keep you from still having to transact with the outside world. I'm still signing a message, or I'm still accepting someone's password. I still have to present that to the other end, to the application on the other side. And so that's not an end all be all, but I think looking for opportunities to use this correctly will help with a lot of the more, we'll say, it's really a shame. For example, I'm thinking about the discussion when Microsoft had their signing key for consumer Microsoft accounts disclosed. And this happened because they had a support case that had a memory dump of a process that was a web server process for Azure AD or for Office 365 or whatever component it was that was responsible for it. But that was not in a secure enclave. That was just hanging out in heap memory to be dumped when the program crashed for a different unrelated reason. And so looking for those kinds of techniques can really help with that link. A similar category, and I say similar because it probably under the hood is relying on those technologies, but just presented in a different facade. But especially on our mobile platforms, again, our big players, Apple and Google, have APIs for saying my application, is not being disassembled, is not being run in a debugger, is not being run on a jailbreak or rooted phone. Apple calls theirs Appatest. There is Play Integrity for Google. But these are basically techniques that say, starting from the bootloader of the operating system being signed and up to kind of a cumulative function of all of the different configuration parameters around that, we're pretty reasonably sure that somebody didn't put this thing in a bench and hook up probes to it and is trying to read what's going on inside of its brain. Cross-platform frameworks, you might find vendors who add some kind of value over these OS capabilities, like they're going to let you deploy with one key to monitor it across all the platforms, and that gives you nice dashboards and management tools around that. Fundamentally, still, you're relying on the operating system and that supply chain to trust things up, but that's a pretty good trust for most of our things, right? If I'm not dealing with somebody who's going to be that motivated to disassemble this, that's gonna protect me from a lot of the casual kind of curiosity and inspection of these apps. I also put web attestation is complicated. This is something that Google had a proposal for doing this in Chrome browsers. It's kind of a little bit of a contentious proposal because it touches on things also like ad blocking and like where can people have code that's in the browser that's from extensions or from third parties versus how can Google prove to your bank's website that you're not running a something with the some information stealer hooked up to it. So that they withdrew from pushing that effort forward. Apple has that kind of attestation for their iCloud relay services, though. So if you are trying to make sure that somebody who's accessing from a particular service is using a genuine Apple device, that has some attestation even at the web layer. So I don't think that's settled yet. I don't think that's something that can be relied on as much as in the mobile apps when you're baking things. But that can be one of the ways to help make it an easier decision to say, I'm going to trust what this application is sending me, or I'm going to trust this pattern of exchange. So kind of thinking back to earlier when we're talking about the secrets that we use for our backend services or the identity tokens that we're passing around, what are the ways that I'm going to manage that use? So yes, I trust my application, but am I going to give my client, my remote client, the key? Or am I going to give them the whole access code? Very often not. That probably is too much at the open end of the spectrum. And so kind of one design pattern for that is to simply proxy requests on their behalf and make your application into a very fancy, but a little bit glorified proxy. You're going to take your whole request, you're going to pass it on to your backend service. You're uploading your photo of your employment agreement. I'm going to put that in S3 for you, but you're going to give it to me first. And then if that succeeds, I tell you it succeeds. If it fails, I tell you that fails. You tell me you want something, I look at what it is and I go fetch it. This is, I think, it costs a little bit of performance in this architecture. It costs bandwidth, compute, but you get to see what's going on in your application. And if you need to be able to get a high degree of granularity of maybe I'm auditing what people are looking at, who looked at it when, from what account, from what location, I like this approach the most because I can really look at that. And I could put a mitigation here, right? I could say, well, you told me it was a JPEG. I'm only going to allow JPEGs. I'm not going to store an MP3 into S3 or an ISO into S3. On the inverse side of that, if I do something that doesn't lock this down very well, I'm going to be paying for it maybe twice over because I'm computing on it. You're suddenly flooding this with a BitTorrent segments for something. Again, I'm thinking a lot about file upload. Now my application's processing all of that, and I'm stuffing it into the back end because I wasn't actually looking at it. I just wrote it this way because that's what ChatGPT told me to do. I like ChatGPT fine. There's no problem with that, but we don't copy and paste Stack Overflow either, right? So the other approach for doing that, if your service allows it, is signing requests or getting signing keys from that or getting signing signatures from that service to sign a request. So the pattern here would be, I want to do an upload. I trust the application. I'm not going to give the application my access credential for S3, but what I will do is I will ask S3 to give me a signature token that I can then give the application. It's good for exactly one request to the place I asked it to be. And again, depending on what service you're working with, they can do this. They can get granular with this. Maybe have very granular permissions, or what the file is going to be named and the destination, things like that. And I like that pattern for, again, just kind of keeping it a little bit, having less going through the application, but I'm not going to have as much visibility of what they were doing with that token when they got it. Did they, I might have to do something like check back later to see if that file made it there. I might have to take on some other kind of overhead that way. But I think the choice between taking either of these approaches is going to turn on where that cost and latency penalty grows. So am I doing something that is rarely done, that, like, if I'm thinking about an employment application, I'm only uploading a picture of my driver's license once or twice per maybe year. But if I'm doing something that has a high volume of traffic and it's, I'm providing a real-time chat and that's being backed by a cloud service, I probably don't want to slow that down any. So making that kind of context is what I would say goes into choosing between those models. So that's kind of those are the slides I have. I think the kind of wrapping point to put out really is we're in the security side of things. I think really going to be well situated for helping our teams spot these vulnerabilities, helping our teams understand that they've set something up, and how can we pass it on to the folks who are implementing things operationally, which is how I wear my day job as well, to design these systems to be secure out of the outset and follow these kinds of principles. So yeah, any questions about the tail end of that, or questions in general? Yeah.
Just a quick question. The core of your app is not hard coding any sort of credentials into itself, but you're requiring the user to do like a lock phone login.
Mm-hmm.
And you get back, say, an access and refresh token. Would you want to store those in like a secure enclave, or is it fine to just use like core data or something for that? So, and I'm going to repeat the question just in case the recording didn't get it, but the question is, if I'm getting something like a refresh token back for somebody who authenticated with OAuth, that's sensitive, that's going to let me stay logged in as that person. I'm a mobile app, where am I going to put it? Am I going to put that in an enclave? Can I treat that as normal data, core data on iOS? I think on iOS in particular, for example, so the secure enclave, its API doesn't let us give it key material. So it's almost air gapped in that it neither accepts key material nor produces its key material. But there are related APIs like Keychain that provide some more at rest encryption, similar concepts on Android and similar concepts on if you're doing any Windows apps as well, where it'll be armored, so it's at rest, not going to be unlocked for free. But again, conceptually, if somebody got the whole phone, right, there's a chance that with enough motivation, again, if I'm up against NSO group Pegasus, if I'm up against a state actor, that they're going to have a means to get that. And then I say, is that trade-off okay? So method-wise, using definitely something like a keychain, something that's specific, purpose-built for authentication credentials, is going to do me a lot of good, especially if they improve over time, right? So say a future implementation of the keychain is even more enclaved, or what have you, versus, and we also see that's also how biometrics work. When you use biometric auth on iOS, it's creating a secret, but that secret is retained in the enclave, and it's giving you back a token from that secret. So I'm answering two different things besides just the one question you asked, but yeah. So on the topic of secure enclave, I think it's called Trust Zone on Android.
What other, have you seen there be an increase in similar systems or similar subsystems on like other types of consumer devices? So like laptops, desktop computers. I know Apple's one of their big selling points on MacBooks is they have like a T1 chip that
Yeah.
handles encryption at rest and presumably also has something similar to the secure on it, if not exactly the same thing. Have you seen anything similar to that cropping up in other contexts?
Yeah, and so the question, in the line of trusted execution contexts, we talked about mobile. Is that kind of happening in the desktop space, and is that increasing? I'm not an expert on desktop apps in the same way, but what I will say is, short answer, yes. Microsoft has the like Windows Hello APIs that are a lot more tied to the TPM, either an actual discrete TPM or a soft TPM that's built into the chip on x86 or x64. But I'm not sure what are the specific constraints or considerations for that for them. I see it. I'll put it differently. I see it when I use things like 1Password, and I'm seeing 1Password hook into Windows Hello features, for example, where they're trusting Windows Hello or giving you the option to trust Windows Hello with your key material. So I think as that platform becomes more available, because again, that's also like the, can't upgrade to Windows 11 if you don't have a TPM unless you type the secret disable code. But ideally everybody gets a TPM and everybody has a trusted-ish or trusted enough space for that on desktops as well. The trick, to me, the difficult part for that is if I'm writing something that isn't native code whatsoever, that's not a web app, that's not a mobile app, it's not a desktop app, it's a web app. Yeah, I have local storage. It's kind of almost like you're saying with core data, right? Like, yeah, I have a local storage. I'm not really gonna feel good putting that in a client somewhere, because something's gonna come along and scrape that, and information stealer's gonna come along and dump all my cookies, dump all my local storage. So it leaves the distributed web apps in still out in the cold a little bit on that, but yeah, good idea to get more people there. Maybe there'll be a web API, web authentication API, I think starts to get in that direction too, like passkeys, but
Passkeys, interesting.
cool. Well, I appreciate y'all's time, and hope we're able to share some ideas that get you thinking about what's happening in your lives, your world. I'll be sticking around to chat for a bit, but also understand when people can't talk about what they're working on. So,
Thanks.
thank you.